Okay, welcome. It's been a while, so we are waiting for 6 minutes, and we are stating very low attendance. I'm not very sure what's the problem, but okay. I keep on motivating people to attend the classes, but somehow they are very comfortable with uh, attendance on videos. Okay, so this is very surprising. Anyway, so let's jump back. Let's go ahead and learn because today's topic I explicitly told in the last video that it's very important. So let me share my screen and let's begin. Okay. So let's start. Let me share my screen and we should start. Okay, so our today's topic is how to handle errors because up to this point we saw a lot of errors coming through in our application. Whenever we are writing the code, whenever there is a risky code in our application, our functions, we got errors, right? And what we do with that errors? Okay, we are not doing anything. Basically, we are just trying to avoid them. But remember that there will be certain scenario in future that you might not be able to avoid the error. You need to handle it properly. Okay, so there is no code which is 100% proof, foolproof. Okay, that's not practically possible. So how do I avoid writing that kind of coding, or how do I making sure how do I avoid that error message, a flash error message in red color and all? How do I do that? So that's what we need to work on. So let's start. So let's go ahead and learn how to handle errors. Okay, sorry about that. There was a network glitch, but this is fine now. So are you able to hear me now? Are you able to hear me now? Okay, so coming back, sharing my screen again. And what I was telling you is, okay, hold on. Let me know if you're able to see the screen again. And I was talking about errors. So how do I create an error? How do I create an error? So let's start. Let me create a Python file. And let's say test error. So up to this point, we faced a lot of errors, right? So let's create one of the error. And one of the simplest error I can show you is let's access something in the list which is not there. Look at that. So let's say sample list. We did this, right? Yesterday itself. In yesterday's class, we saw how to access list. So let me create a list for you. And here it's, let's say 100, 200, 300. And what I'm going to do, I will be accessing an element which is not there. So sample list dot sorry, not dot dot. You are just accessing, let's say, item number 4. There is no item 4, so you'll definitely get what? An error. Correct? Yes or no? So here you go. If I run this class, I'm basically accessing something which is not exist. So you'll get something called like this: index error, list out of range, list index out of range. Now, in practical scenarios, there might be hundreds and thousands of different scenarios which can lead into such kind of errors. Correct? How do I avoid that? So this particular framework, which is called as exception framework or exception management framework or exception handling framework, all these names are same. are basically taken from Java. Basically taken from Java. Okay. So let's try to understand how this framework works. This is called as exception management. So here we will do try. Inside that there will be a risky code which may lead to an error. Okay. And then you say accept. And accept is basically like which error you are talking about. So error. So with this, and then you say error handling logic. So whatever error handling logic you want to put it, you can do that here. I will give you a normal recommendation. Never write a business logic inside except block. Except block is not created for business logic. Okay, always remember this. Cool with this? I'll also write that tip. Business logic should not go here. Okay, now let's try the exact same scenario with the help of this try catch or try accept, shall we? So here you go. I'm going to use this try accept logic for this sample list access. So I'm writing try, and in try there is a block. I'm accessing the sample list 4, and here I am saying accept, and I'm not writing anything. I'm not writing anything. Okay. So in accept, I'll be writing, let's say print. There was an error. That's it. Okay, so this is optional. So by the way, error is optional. You may or you may not give this. So let's run this code now and see what happens. If I run this, I'll get there was an error. I'm not getting any error because of this. But how do you figure out like which kind of error came? Correct? You don't know, right? So if you're very sure which error is going to come, you can specify that error here. So as of now, I know that there will be an index error. So you can specify that error here. That is completely okay. If you run the code, you'll get exact same stuff. But you lost the message, right? Last time when we executed this, we got a message. Okay, index out of range, something like that. How can I get that message? So you get that with the help of as. So give as, and as is nothing but alias. So we are actually giving an object to index error. So we are saying as IE. So whatever index error giving you, give it as IE, and then you will get a message out of it. Okay, so now I will handle the IE, handle index error and also print the message. So with this, so if I run this, here you go. I'm getting list index out of range. So I got message also. Are you clear up to this point? Are you clear up to this point? Because exceptions are very deep. Okay, so we're gonna take one step ahead. Okay, so now index error. How do I know that this is index error? I might not. Okay, so how do you know that how many errors present in Python? Practically, it's not possible for you to remember all of the errors, yes or no? So now in Python, there is a higher, what I can say, parent class of error is available, which can be used to handle all of them, How can I see that? So suppose I open index error. I can say index error is basically the parent class is called as lookup error. If I see lookup error, I can see that the parent class is exception. So if you are handling exception, basically almost all the Python errors are being handled. So you can go back here and change that to exception. Exception IE or EX. And then you will be able to handle that. And now the code will behave exactly the same. There will not be any change. You will see that index out of the error. As a matter of fact, if you are accessing any other errors also, it will be handled with the help of exception class. So when you don't know what to handle, you can always handle exception. And when you know exactly what to handle, then you can handle specific errors. But can you handle multiple? Yes, you can handle multiple errors. Absolutely. No problem, sir. You can handle multiple errors. How can I handle multiple errors? With the help of multiple except blocks. So if I am handling other error here, let's say except and I say index error. as IE, and then you can have print, and you can just see this is specific error. It's a specific error. Okay. So what's going on here? I have two exception blocks. You can have different exception logics. Clear? So suppose let's create another scenario where I'm using total or div equals sample list divided by, and let's say comma 0. So let's say sample list 1 divided by sample list 3. So what's happening here? Sample list 3 is basically 0. Sample list 1 is basically 200. So what's happening? Here basically it's getting 0 division error. Correct? So if you are getting an error which is not handled by index error, okay, then you will get this particular message. Okay, let's run this code and see the magic. Okay, there was an error and you said division by 0. Okay, if you remove this block and run this code, you'll get an error which is not handled, and that error is 0 division error. Okay, so I can handle that with the help of an except block like this. Except you say 0 division error as ZDX, and then you can handle print wrong division and pass ZDX. Correct? You can do that, and now run. You'll get wrong division by 0. Cool with that? But what if I don't want, see, if I want an exact same logic to be executed for all the others, I will end up writing so many except blocks, right? That is ridiculously bad, correct? So no, you don't have to do that. You can collect multiple errors into a single except block. That is possible. You can collect multiple errors into single except blocks. So what you can do, you can just say comma and 0 division error and just put them in a bracket so that Python will know what exactly you are doing here. So now you are saying index error and 0 division error, and you are saying as is ex and pass this ex. So whatever comes in, okay, you will be able to handle it. Okay, whatever comes through, both will be handled with the same block of code. Cool with this? So let's test this scenario. So run this, we'll get the specific error division by 0, and let's add this one. Specific error list index out of range. So both the errors are basically handled by the single block. That is possible. Cool with that? Now you can you still have an exception? Of course you can. So you can still have an except. You know what? If you want to write exception, instead of writing that, don't write anything. Instead of writing an exception, don't write anything. You can just put except, and that is also fine. So this is called as, this is generic error handler. Generic error handler. And you don't actually specify which kind of error is coming through. This is completely possible. What you should not do is, you cannot have, or you should not have, the generic error handler prior to specific error handler. Then there is no meaning of this. See what exactly Python do. Whenever there is an error, it will check the except block in order. So it will check whether I can handle the exception here, and the answer is yes. You can handle exception block here itself. So whatever you write after that has no meaning. That's why it's a red color. So the error, the except block should be always in a order. And what's the order? I will write that down. Remember that forever, especially for interview. So here you go. Except blocks are always how? Specific first, generic later. That's how it is. So specific first, generic later. That's how it is. Cool with this? Always remember this. Always. So if anything else comes through, that will be handled by generic block. And if these two comes through, that will be handled by specific block. Is this clear? So try risky code, except block, optional errors. If you know specific errors, you can have that. You can combine multiple errors and have a single block of code to handle that. You can have as many except block as you want. No issues with that. An exception block should be what? Specific first, generic later. Cool with this? Now there is an additional block given to try except is called as finally. So finally is something which gets executed regardless of exception. So if I write finally is something which is executed regardless of exception. So this will execute regardless of exception. So if there is an exception, this will execute. If there is no exception, this will execute. Cool with this? So this is called as finally block. Finally block. When exactly you should use finally block? So suppose you're opening a file, then close it in finally. So no matter what happens in the logic, file will be closed. If you're opening a database connection, close it in finally. If you're opening a ActiveMQ connection, close it in finally. If you're opening a network connection, close it in finally. Okay, so all closures, all finalizations. If you're creating a huge list, clear it in finally. If you're creating a huge cache, clear it in finally, because you need to use memories, right? So all these things should be done in finally block, so that no matter what happens within the try or catch, you will always be safe. Correct? So finally block is a savior. Okay, so if I run this code, you will see finally block execute regardless of exception. Okay, but my project leader told me that if the process completes properly, then send an email. If the process doesn't come, an exception comes through, don't send an email. I have this scenario. So how do I do that? Either I have to write flags for that, like there is a flag in a try block and everything completes and all those. And only then if the flag is true, I will send them. All those things are not required in Python. What you can add is else block. This is very interesting. In Python, we have else block in try also. Else block in try. So what does else do? Else executes when executes when try completes successfully. Try complete successfully. If there is an error, if there is an exception, then else block will not be executed. So let's make this possible and run this. So see this executes try. Okay, see when try completes successfully, there is no error in try. So we are good in that. Okay, and executes here in else block. And finally, of course, regardless of try and except, finally anyway executes. Now let's make an error. Let's create an error. Here you go. So 3. There will be 0 division error. So run this. See this. You don't have else block now. You have except, but there is no execute when try complete successfully. There is nothing like that. So else block executes only when try completes. Clear with this? So what we learned, what are the rules of try except? So first rule, try has a risky code. Okay, if you know the specific error, handle it in except. If you want to handle multiple errors, you can have multiple except blocks. You can combine multiple errors into a single except. You can handle generic in except block. You can use else when try completes, it executes, and finally executes regardless of errors. These are the core rules of try, except, else, and finally. Questions? Try, except, else, and finally. And you cannot declare else after finally. Please remember that. After finally, you cannot declare else. That's wrong. That's not possible. Okay, you will get an error there. That's not possible. Okay, else should be always before finally. That's one of the rule again. Cool with this? Are you clear up to this point? Then we will proceed further. Are you clear? Type clear in the chat box. Awesome. So let's go ahead. Now, there is a situation, remember that all these things are basically Python specific stuff, but your business is not Python. So coming back to example of pharmacy, so suppose I'm walking into the pharmacy and I'm buying something which needs a prescription or which actually needs a age check. Okay, so on a particular age only, or suppose I'm going for driving license. Let's take a driving license example. So I'm supposed to be at age 18. If I'm not, or 16, so if my age is not 16, I'm not allowed for driving license. So I have this age validation, correct? So let's create that. So let's create a new file and say age validation for DMV. Okay, or we call it a RTO here, right? So it's called RTO, correct? So age validation for, and we are defining a method validate underscore age. You're taking age as an input. Okay, what you do integer underscore age, and you create it as integer age. I'm not worried about that as of now. My logic is if integer underscore age is less than or equals to or probably greater than 16 or greater than or equals to 16, okay, I'll say okay, ready for learners permit, and if not, I'll print invalid age. So this is my method, and I'm gonna execute that method now. So it's a validate age method, and you are passing, let's say 21. I'm safe there. I'm running this, and I'm fine. I got ready for learner's permit. Now tweak this to 12. Run this method. I'm getting invalid age, but I don't really want those messages. I want like if the age is greater than 16, then return true, and if it is not, then throw an exception. Then somebody should get an exception, an error. Okay, error should be generated from my code. How do I do that? That's called as raising an exception. So let's do that. So here ready for program, that's fine, and here I'm returning return true. I'm allowing that, but in else I'm saying invalidate, that's fine, but I want to throw an exception back to the caller. Okay, so how do I do that? I'll say raise value error. There is something called value error in Python. Whenever we have a wrong value, it will get that. So value error, and you are saying invalid age, invalid age. So this is called as exception raising. So you're raising an exception. So see this now. If I run this, I'll get the error myself. It's called as value error, invalid age. So your code is generating an error, raising an error. So now this method itself is a risky code, isn't it? So up to this point, what we did is we accessed something like this, and then we got an error, correct? So because this was the risky code. Here, this method is risky code. So how do I avoid that? By try catch. So everyone who is calling this particular method has to write a try except block. Except block value error as VE, and you say print VE. And if I run this, it will be satisfied. This will find invalid age, invalid age. Cool with this? With TryAccept. So now you created a scenario which can actually generate an error according to the business logic you are written. Remember that Python doesn't care about your business. You do, right? You have to worry about your business. Python को क्या करना है? Python को कोई टेंशन नहीं है कि आपका business क्या है. You are worried about your business, correct? So that's what it is. But remember, the error you are using is still Python error. Yes or no? Error you are using, a value error, is still a Python error, correct? Now, what's the point? You missed the point, right? So let's correct that thing. So let's create our own errors. But how do I do that? So let's open this value error. Let's analyze what we already have. So whenever there is a new error created, we can see that the class value error, and basically it says parent class exception. And it's nothing, it's just calling this particular constructor and saying pass. That's it, right? It has some static method, don't worry about that. But we are saying this. This is basically a call to the constructor of exception. This is it. So can I do that myself? And there is nothing right after that, practically nothing. So I can write my own exceptions. There is nothing wrong in that. So let's create them. So I am writing a new Python file. I'm saying business error, business error. Okay. And here I'll say class invalid age for permit. Invalid age for permit error. Such long thing. That's fine. And you say exception. That's what we saw, right? And only thing it does is you go back and you copy this and paste it. How hard is that? Basically, you are done. So invalid age permit, you created init method, takes self, any number of parameters, any number of keyword parameters, that is up to you. So if we really do not know what parameter is coming through, then use these two. You know the meaning of this, any number of parameters as a tuple, any number of parameter as a dictionary. Okay, and we are fine with that. If you want to print something, you can actually use this, or you may pass, simply pass, don't do anything. Okay, let your parent handle the stuff. So can I use this invalid age for permit? So let's do that. Let's use this. So instead of value error, I want to use invalid age for permit error. How can I do that? Did I tell you how do you import a class? How can I import a class? Okay, what you have to do is you have to provide that import here. That means I'm getting an error here because this is not known, correct? So you can import like this, import learn06 business error invalid age error. That's one way, or you can just say from learn day 06 dot business error import invalid age error. This is how the format is. Okay, we will learn about that in modules. Okay, so now I have my own error. So this one is called as custom errors. Okay, so now I'm handling my own error. You know what? If you know it very well that this business error is a value specific error, you can even make a parent class as value error. But with that, a parent class can be value error also. So if you know there are specific errors already written in Python, you can override them. Or sorry, you can make them parent, or you can use them for your own methods. So let's do that. Let's handle invalid age error here and run. See invalid age. We try accept invalid age. Got it? So you are creating your own exceptions. Cool with this? So what are the stuff we learned? So this is it. There is nothing beyond this. So generating an error. Okay. Whenever there is error generated, what you want to do, you will be able to handle that with TryAccept error clauses. We saw multiple except blocks also. Else, what is the use of else? And finally, then we saw how do we raise an error, and we raise that because we want to call out the risk. What does it really mean? Calling out the risk. Okay, letting people know that this is a problem. Somebody should handle it. And who handles that? The people who call it. Simple as that. Okay, so invalid age error. So how do you handle that? With the help of TryAccept. Now we have to get rid of Python's errors and include our own errors, because in future, when the code is being maintained by somebody else, that person has to understand this is not a Python stuff. This is specific to the business. In that scenario, he gonna use invalid age or permit error. Good with this? So that's why we are creating our own exceptions, and we are using that with a TryAccept. Correct? And we can raise in with the help of raise command. Is this clear? So TryAccept else, finally raising an exception and custom exceptions. This is all about errors in Python, or error handlings in Python. Okay. Questions? Questions? Just a minute. This is something I have to take. Sorry about that. Okay, so are we clear about the things which we learned today? Is there any open question? Okay, so now I'm going to share your assignments with coding things. Good with that? And you have to try working on that. So let me show you those assignments real quick. Give me 1 second. What exactly you have to do is, so these assignments are for coding practices. These assignments are not related to any of the business scenarios. These are very specific to coding practices. Okay, please remember that. So let me show you that right away. Here you go, week 1 assignments for week. Opening it. Okay, so are you able to see this? Yeah, see this, getting user input, manipulating the strings, question two. There are questions actually, problem scenarios, and you have to work on it. It is covering all the topics which you have learned, okay, up to this point. So there are 6 questions in this. This is your assignment number 1. There is another assignment which has 13 problems, and I call it as programming skills assignment. Okay, and I will share this particular programming skills assignment with coding things. Okay, so that you can start working on it. So two things. One thing is these 6 questions. These are core practice for Python, and another one is this one, which is assignment, which has 13 problems into it. All these things will be shared with coding kits. What you have to do is utilize your weekend and try to answer these assignments. And whenever you complete this, okay, all 13 of them, all 6 of them, and all of them, or if whatever you complete, let's say you completed 5, you want it validated, what you have to do is create a zip file, okay, and send it across to me. Okay, how? Through coding kings again. So you know the WhatsApp number, you can connect with them, send them files, and they will get in touch with me. Well, with that, so this kind of interaction should happen. I will validate the code and provide you feedback. Okay, so if you want to connect for feedback, okay, we will check that. We'll make sure that you go through all those stuffs and make sure we understand also. This will actually check all your understanding properly. Are you all in sync? Is this clear with you? Can you utilize your weekend for these assignments? Because we learned a lot of part, but we are not practicing enough. We have to start practicing from this week itself. Is this clear? Are we all good? Okay, so these 6 questions are coming through, and these 13 assignments are coming through. So complete 6, create a package, send it across. Complete 13, create a package, send it across. Let us validate. And if there is something which you want to discuss with me, let me know in the class. We will connect and get the difficulties resolved. But you know what? Unless you make your hands dirty, unless you literally write your code in your bare hands, nothing gonna happen. Okay, जब तक हम खुद से नहीं करेंगे कुछ नहीं होने वाला. Okay, so we have to do it with your own hands. Good with this? So let's start our assignment. Okay, Saturday, Sunday, utilizing that particular thing, and let's connect again on Monday and make sure we are making progress. I will also send a course tracker to you so that you can see where exactly we are in our entire journey. So today's topic is small, but it's very important for your future. So let's stop here and let's continue on Monday. Thanks a lot, everyone. Have a good one. Enjoy your weekend and be safe. Thank you. Bye bye.